Let's discuss normal distribution. This distribution is the most important one in statistics. Used to study very well. Consider this example. If you watch continuous data, then you can see that it looks like a bell shape. That means a large collection of data nearby mean, and fewer data as it moves away from the mean. It is symmetrical around the mean. We call this type of data follows normal distribution. Maybe your height data, weight data, some kind of length. Many of the data follows this normal distribution. But how do you calculate the probability of normal? You need some kind of a frequency table, histogram. You can answer that. But mathematicians, statisticians try to find some mathematical function and approximate the probability, as I mentioned in the previous section. De Moivre, the Gauss were contributed to find the one mathematical function look like this. This is a functional form, a little complicated, and depending on mu and sigma, we denote normal as n, capital N, and then mean value, standard deviation. Well, in this case, we have a small, no, not standard deviation, this is variance. In this case, we have a little skinny normal. It is flat normal, 0, 1, normal 2, 4. Well, if you have a normal distribution, it has characteristics like this. It is a continuous function in the shape of a bell, symmetric about the mean. That means the probability is half and half. Also, there are infinite number of normal distribution depending on mu and sigma. You can switch mu and sigma, and you can pull out any kind of normal distribution. The most simplest one would be mu equal 0, sigma equal 1. That is this distribution. In general, you'd better remember these things. You'd better remember this is mu plus minus 1 sigma interval. Sigma is some kind of distance from the mean. Mu plus 1 standard deviation is 68%. Mu plus 2 standard deviation is 95%. Mu plus minus 3 sigma is 99.7%. That means it will include almost all data. But possibly it can have an infinite value. But plus minus 3 sigma is almost all of them. How to calculate probability using this mathematical function? You need integration, as we discussed in the previous section. But unfortunately, it is not integrable. We have to use some kind of computer calculation, which is impossible for you. You'd better use E-stan in your case. And let me discuss this first. There are so many data, so many random variables, so many normal random variables. But luckily, if you have one transformation, do you remember that? From random variables, subtract mean, divided by standard deviation follows the normalization. Mean is 0, 1. In case of normal, it becomes normal 0, 1. Therefore, when you calculate some probability related with general normal distribution, you can convert to normal 0, 1. That's good. Therefore, well, in the traditional textbook, they provide some kind of table. But in case of E-stat, you don't need it. But let's see how it look like. Are you ready to use E-stat? Type this, estat.me, click E-stat new. Here, click normal distribution. Will give you these things. It is normal 0, 1. You may switch this mean and 1. In case of a normal 0, 1, let's say you already saw that, for example, from -2 and to 2, and then click execute, or you may just hit enter, then they automatically calculate this probability, that's the integration between -2 and 2, become 95%. Okay. Well, in this way, you may calculate this probability, that's the integration from actually negative infinity to this point will become, negative 1645, it will be 5%. Maybe you can use this type, right-tail probability. Then you can calculate the percentile, for example, 0.9. What is the percentile value such that this area is 95%? This is the way. Okay? If you type this number, enter, they're going to provide you this value. Similarly, this is left tail 5%, right tail 5%, and so on. Traditional textbook, they provide you this table. You typically from negative 4, 3.9, 3.99, they provide you some accumulated probability in this way. Therefore, we have to teach some trick how to calculate probability of interval. But using E-stat, you do not need that. If you want to calculate the probability of a certain normal, type some mu and sigma and give some interval, click execute, will give you answer. Let's go back to slide. We are here. I showed you this. How can you calculate this probability? I already showed that. Where is that? Maybe we can calculate that. If G is standard normal, normal 0, 1, we call it standard normal. What is this probability? It belongs to this type. Okay. Suppose if I type 1.96, enter, they're going to calculate the probability is 97.5%. Okay. Well, similarly, you can do here, minus 1.96, 1.96 to this value, 1.96, and then click enter, will give you 95%. Similarly, you can finish this calculation. Maybe this is this type. You can say type 1.96 will give you right tail probability is 2.5%. And suppose G is a standard random variable, you can obtain X. Actually, this is percentile. Can you see that? Where is a similar expression? Well, this is it. Suppose I want percentile like 0.9, enter. This is 1.282. You may calculate some interval such that 0.99, that's this type, click 0.99. it will give you answer like this. Maybe it's the same thing as third style. Actually, you have the answer. Okay, when right to 5 percentile is 1.645. By using E-stat, calculation of probability is so simple. For later user, please remember this kind of some percentile value. From the left side to here, 1.645, the percentage is 95%. 1.645. 1.96, 97.5%. Well, 2.575 is 99.9%. If you consider two sides, I mean, we are talking inside the interval, plus minus 1.645 is 90%. Plus minus 1.96 is 95%. Plus minus 2.575 is 99%. Please remember this 6 value. It will be used frequently. You don't have enough time to look up this E-stat. You'd better remember this value. Well, if you are using E-stat, you don't need to know, but at least you know the basic. Suppose X is a normal distribution. I want to calculate the probability. What is the step? Normalize each value. That means subtract mean divided by standard deviation. It looks like this. Then it becomes Z distribution, no standard normal distribution. Then you can look up this table. But that's the way of calculation, or rather than using, maybe in case of E-stat, well, you can directly enter mu and sigma, but for later purpose, you'd better remember this idea. I mean, switch to standard normal and then calculate probability. Here's the example. If you want to calculate this probability, normalize it. Subtract mean divided by standard deviation, and this is a standard normal. And using E-stat, if you're looking up, it's a 0.9925. Similarly, this kind of interval, subtract mean divided by standard deviation in each component. That means Z standard normal random variable, we are looking this interval, go to E-stat, find this value. Well, you may consider this kind of example is a percentile. Suppose I want to calculate 95 percentile, then this problem look like this. In case of normal 0, 1, if you looking up this table, it's 1.645. In a general distribution, it's a reverse of standard deviation. What does it mean is 70 plus 1.645 times standard deviation. Why it happened? Because, well, let me show you. Standard deviation, standardization imply, no. Z value imply x minus mu divided by standard deviation. If I solve this problem, is x equal mu plus this is mu plus Z value times sigma. This is the inverse of Z transformation. This is what we applied. I mean, the value corresponding to 95 percentile is equivalent to 70 plus that Z value times 10. Please keep this in mind. And similarly, if you have this one, two-sided some interval percentile, such that 95, then it means that value may be calculated in this manner. That means it's 1.96, and then you can transform in this manner, 70 plus minus 1.96 times 10. Well, normal distribution can be used to approximate binomial like this. Normal distribution can be used for binomial. Do you remember binomial has expectation NP, and then the variance is NP times 1 minus P. Therefore, if you want to approximate normal, if sample size is large, like it has a 5% in defect rate. If you collect 100 product, then it is not easy to calculate the probability of binomial. Then you can approximate in this manner. It is a binomial NP, therefore mean is 5, variance is 4.75, and you calculate using normal distribution. What is the probability of x equal less than 2? Well, subtract mean divided by standard deviation, it looks like this. If you look up the table, the probability value like this. Okay, this is all. I think the normal distribution theory, it is very important. Please review several times. See you on next lecture.